Hello, my name is Lev Sorokin and I present OpenSBT, a modular framework for search-based testing of automated driving systems as a joint work of fortiss and D&D Germany. The motivation behind OpenSBT is that a lot of research conducted for the vital testing of automated driving systems, as it is an efficient approach to identify corner cases where the system fails to satisfy safety requirements such as to avoid a collision with a pedestrian. In particular, search-based testing is used where the system under test is exposed to different scenarios, as the time of the day is varied or the behavior of surrounding actors is modified. To perform search-based testing of automated driving systems, one needs to provide different search-based testing components as the scenario, the fitness function, the search algorithm, and integrate the simulator, but also to provide an output analysis in the search for the user. The question is now, how can I engineer a pipeline which I can use with different search-based testing components for different use cases without the burden of implementing the connections between the components from scratch. OpenSBT abstracts the definition of the search algorithm, the fitness function, the scenario, as well as the simulator to allow the users to integrate the components based on their needs. It also provides an automated output and analysis for all critical scenarios, and the framework builds upon the multi-objective optimization framework PyMO.
Demonstrate OpenSBT on testing 2AB systems in the prescan and color simulator. We use the same fitness function but different search algorithms in a scenario where a pedestrian is crossing a vehicle's lane.
To perform testing, we need first to define an ADAS problem. An ADAS problem receives as input the definition of the search space, we pass the path to the scenario, the variables to be varied, and the bounds. Further, we need to specify the simulator by assigning the simulate function and define the fitness and criticality function. In the bottom part of this figure, we see the definition of the search algorithm and assignment of the configuration of the algorithm that holds parameters such as the population size and number of iterations. On the next slide, we show how to define the reference search-based testing components. To integrate a specific search algorithm, simulator, or fitness functions, OpenSBT provides interfaces and abstract classes. For the algorithm integration, the optimizer provides the methods init and run, where existing or user-defined algorithms can be integrated. The simulator is integrated via subclassing the simulator class and implementing the simulate method. For this demo, we have implemented extensions to integrate the color in the prescan simulator. To define the fitness and criticality function, the user has to implement the eval method of the respective classes. More detailed information can be found in the README of OpenSBT.
Further, we have provided several Jupyter notebooks to explain step by step of how to use OpenSBT.
Now we demonstrate the execution of search-based testing with OpenSBT. To execute the color experiment, we need first to start the color server. We use the implement color runner for this. Then we go to OpenSBT and use runtime and pass the experiment name, number of iterations, population size, general scenarios. Then we see the first simulation in the color simulator. In this scenario, the vehicle could not avoid the collision, and the simulation continues with the next scenario now. Change the fitness function. You just need to pass the instance of the corresponding fitness function. Here we use the function based on time to collision. We can assign then also an appropriate criticality function for this. We can also easily change the search space. Here we remove the distance to the vehicle, the search variable. The pedestrian starts moving, and then we see in the output that we have started the experiment with exemplary configuration, that we have only two search variables.
For the prescan example, we passed the scenario in the PP format and the simulate function of the prescan simulator class implemented before. Having implemented and registered the NSG2DT algorithm, we assign the corresponding algorithm type with the experiment definition.
To run the prescan experiment, we need first to start the MATLAB Simulink in the prescan environment, then we can run the experiment similar as in the color example. OpenSBT will then connect via the prescan runner to the MATLAB environment and start the search and execution of the system under test and the generated scenarios. When the search is terminated, several result outputs are generated. OpenSBT outputs a detailed list of all available test cases containing fitness and criticality values. Also, two-dimensional plots with axis trajectories are generated to understand what happened in a critical scenario. Another feature of OpenSBT is to characterize when the system under test behaves critical. Here, all available test cases with the criticality labels are passed to the decision tree algorithm to derive criticality conditions, which can be derived from path conditions in the tree. Here, for instance, we have identified one condition by decision tree learning visualized with the purple region. Thank you for listening and check out our tool OpenSBT.